So we are now in the section on graphical interpretation of position versus time and velocity versus time. But let's quickly review. You've learned a few equations that we derived from understanding constant velocity based from your reading. So you have this average velocity of an object. We've derived the equation for finding the displacement. We've also able to look into a quantitative description of linear motion in terms of the object moving at a constant velocity. And also I've mentioned about instantaneous velocity, which is related to the speedometer reading in your car. So that tells you the velocity at an instant. So we are now in trying to interpret the graphs that you've done in terms of the walk the graph using vernier. So we've able to understood the slope, interpret them. So we know that A, C, and D and E are similar description. Qualitatively, this is when the object is at rest. And for B and D, this is when the object. So this is in terms of position versus time graph. So in this case, you see that the object is either moving positive or negative, and we've identified this one is moving at a constant velocity, and this one is moving at a constant negative direction. So that is how we interpret this. Now, what happens if you have a velocity versus time? So let's take a look at this quick video and see a little bit of an analysis on graphical representation. So this is a video of a runner. Runs for about 40 meters, went back to 20. So how do we represent its graph of motion? So go ahead, pause this video and try to draw that. Does this look similar to this? Well, let's find out. So looking at the graph, oh, looks like similar. What about the velocity? Let's take a look at the velocity. So the object is moving at a constant velocity. So where is the object when it's at its constant motion? So let's take a look at a section in there and then pause it. So if you're gonna look into, so where does this represent? Which slope represent? Which line represent? So ignore the vertical lines. Those are lines that connect the motion of the object. So let's look at the horizontal line. Those are pretty important. So in this case, this represent which one? This one should represent that. Let's find out. There you go. So what happens if the object is moving at a constant velocity? You see that the line is a vertical above zero, or rather a horizontal above zero. So that is how we represent the motion graphically in terms of velocity. So you should be able to understand the concept behind. So the object is at rest. This is how you see that. And if the object is in motion, you'll see it's a horizontal line. So since it's going back, so it is negative in terms of velocity. But in terms of position versus time, it's positive because the distance is positive, as in this case. But in terms of velocity, since a vector quantity, we add direction, so we represent that in a different way as position versus time. So that's how we describe that. Another way in terms of graphical interpretation is when we look at some trends in the graph. So if we look at this, we can find the displacement as well. So we can find the displacement of this. So look at those shaded part. what are the shapes of this? So if you look at the area under the line of the velocity graph, so you'll find out that the area here can be derived, right? So how do we find the area? What's the shape of the area? Yes, it's a what? It's a rectangle. So how do I find the area of a rectangle? Now what about the area of the shaded part? That is the right triangle, right? What about this one? Oh, it's a combination of a rectangle and a right triangle. So how do we find those? So go ahead, review your equations on this. So you should be able to get all this equation and you should be able to find the answer. So what's the area for this object that is traveling at this particular velocities? And you could also tell here the velocity is what? Is it changing or not? So it's not changing, it is constant. This one, the velocity is changing, but at a constant rate. This one, the velocity has started at 2 meters per second, and it's also increasing, but it is increasing at equal interval. So its instantaneous velocity is constant. So you should be able to get the answer here. So what's your answer here? You should get 36 meters. You should be able to get 18 meters, right? And then you should get about 24 meters. And all this represent one particular quantity in physics, and that is displacement. So you can find the displacement by looking just on the area under the line of the velocity versus time. So what if you're looking at the position versus time? What will be the area? So come to think of that, what might be the area under the line? So that area tells you what? Yes, correct. That tells you the total path covered for that particular point, and that gives you the speed at that particular interval. Okay, so